Alright, so in today's notes, we're talking about per capita personal income. That's a really fancy way of saying the average annual income per person in the United States. So anyways, according to the U.S. Department of Commerce, they can model the average income, average annual income, using the model P of T equals 15.1442 T squared plus 98.7687 T plus 1,831.6909. And this function only works for the years 1960 to 2000. So the practical domain of this model, if our beginning year is 0, I need to see how many years 2000 is from 1960, so I subtract them, which gives me 40 years. So my practical domain is 0 to 40, because the model only works for those years. Number 2 wants me to go type these into my graphing calculator and fill out the table of values. So T is the number of times since 1960. So 1960 is 0 years since 1960. 1965 is 5 years. 1970 is 10, 15, 20, 25, 30, 35, 40. Then what I want to do next is I want to go to decimals. So I'm going to type in my equation, the really fun 15.1442x instead of t. Ooh, not right. And then what I want to do is I want to turn this into a table of values. So I go to edit list and I press convert to table. And instead of starting at -2, I want to start at 0, and then I want to count by 5s. Right over these. Okay, so now I have my values, and number 2 says to round to the nearest dollar. So for 0, I'm going to have 1930. For 5, I'm going to have 2309. For 10, I'm going to have 3,445, because the 89 cents makes it round up, or 88 cents. On 15, I have 5,338, because the 0.9 makes it round up. For 20, I have 7,988. 25, I have 11,396, because the 0.5 makes it round up. For 30, I have 15,560. For 35, I have 20,482. And for 40, I have 26,161. Okay, so I'm going to show you my filled-in chart. Number 3 wants me to sketch the graph, and it gives me the window I want. So I'm going to go back to decimals, and remember to change my window. I go to this little wrench in the top corner. It wants, for my x-min, it wants -5. Where'd my wrench go? For my x-max, it wants 45. For my y-min, it wants -2,000. And for my y-max, it wants 35,000. Okay. I will adjust a little bit because the recording window is out of there. So this is what my window looks like. So I'm going to go back to my paper and sketch that graph. Number 4 wants me to estimate the per capita personal income in the year 1989. So what I want to do is figure out how many years later it is. So I'm going to do 1989. Ooh, that line is not pretty. 1989 minus 1960, which gives me 29 years. So what I'm going to do with the 29 is I'm going to plug that in for the t value in my equation. So I have 15.1442, and then parentheses, instead of t, I'm going to plug in 29 squared plus 98.7687, and then I'm going to do parentheses 29, ooh, that's in my way, and then plus 1831.6909, and then I'm going to go back to decimals, and I'm going to type that exactly like I see it. So I'm just going to do it on line 2. I have 15.1442 parentheses 29 squared plus 98.7687 times 29 plus 1831.6909. So it doesn't tell me what value to do, so I'm going to round it to the nearest whole dollar like I did for the table. So it's going to be 17,432. Number 5 wants us to figure out when the personal income reaches 20,052. It wants us to write an equation to determine the value of t when this happens. So it's telling me P of t equals 20,50,000. I'm going to go and replace the P of t up here with the 20,50,000. So I'm going to write 20,500 with that. So all I have to do for that one is just rewrite the equation with the 20,500 instead of P of t. Moving on, it tells us that kind of equation is called a quadratic equation. Those equations have a polynomial of degree 2, so that means the highest exponent has the highest exponent on a variable is 2. And the standard form is ax squared plus bx plus c equals 0. So standard form does not have a number on the other side of the equation other than 0. So one way is to solve it graphically. What you need to do is you separate the two functions, and then you determine where they cross. So what you do is, I'm going to have y1 equals the 20,500. I don't know why I can't say that right. And then my second one is going to be that 15.1442 x squared plus 98.7687 x plus 1831.6909. And then I'm going to go back in. We can have up to 2 solutions when we're solving this way, but number 6 is wanting to make sure our answer makes sense. So when I go graph it, I want to make sure it makes sense. On Desmos, if I want to graph a straight line, I have to do y equals. There we go. And then I'm going to have y equals 15.1442 x squared plus 98.7687 x plus 1831.6909. Okay. So if I look, it is crossing twice. It's crossing over here at negative 38. and it's crossing over here at positive 32. I only care about the x values here because the y values are the red line. So, looking at this and considering the problem we were working on, the years that worked for this problem were 0 to 40. So I only care about the right side of this graph. This side doesn't make sense because I can't say 38 years before 1960 people were making money. That's not quite how it works. So if I go back over here, my answer that makes sense is 32 years. So what I have to do is add back to 1960, which gives me 1992. Okay, that's the year I was born. Okay. Another way to do it is if I subtract the 20,500 from both sides, and I get this equation, 15.1442 x squared plus 98.7687 minus 18,668.3091. And then we need to find where the graph crosses 0 in this case. So when I have two equations, I want to find where they cross each other. I'll just throw my pens on the floor. And then on number 7, if I just have one equation, I did it again. If I just have one equation, I want to find where the x value crosses the or the y-axis. So I'm going to go graph this equation up from number 7. I'll leave the blue one for now. I'll turn it off. Okay, so if I take a look at this graph, it's crossing the x-axis at negative 38 and at 32. So this one wants us to sketch a picture of the graph. And then find where the graph crosses at 0. So I'm going to write both of those on my paper. I'm going to have negative 38.522 and positive 32. So go back to my paper. That's weird. Number 7 kind of asks the same thing as number 8. So it just wants the x-intercepts. So I'm going to have x equals negative 38.522 and x equals 32. Number 9 wants me to compare the solutions to, what number was that one? That was number 6. So I have 32 in both of them, and it's asking if both values are relevant to our problem. Only 32 is, because you can't go back in time. Okay. Number 10 wants me to describe two different ways. So we can graph two different equations. We can graph y1 equals 2x squared minus 4x plus 3 and y2 equals 2 and see where they cross. Or we can subtract 2 on both sides. So if I subtracted 2, I'd have 1 right there. X squared minus 4x plus 1 equals y, because I just replaced the 0 with the y. Okay, so then I need to compare my answers, so I'm going to go graph. I don't need this. I have 2x squared minus 4x plus 3, and my other equation I needed to graph was y equals 2. We probably want to go home to make this graph look a lot better. It's 0.293 and 1.07. So I'm going to write on my paper the first method gives us 0.293 and 1.0707. Okay. So this new sentence on the bottom is what I wrote. And then I'm going to go ahead and graph the second equation. So I'm going to turn these two off. And the second equation I had was 2x squared minus 4x plus 1. And this is crossing the x-axis at 0.293 and 1.707. So the second crosses at the same points.